Hi everyone, Assalamualaikum. In this video, we are going to discuss example from previous semester papers under higher order partial derivatives. Okay, example 2, given uxy equals to ln 1 plus xy squared. Show that 2uxx plus y cubed uxy equals to 0. Alright, from here we have uxx. So to find uxx, first we need to find ux. And to find ux, we need to refer from u. Okay? Ux here means we differentiate u with respect to x. And we treat x as a variable. So to avoid error and easy to differentiate, we can write variable x at the back. Okay? And we write in different colors, okay, to avoid error, okay. And then we treat y as a constant, okay. Then we can differentiate u with respect to x, so we get ux. After we differentiate ln 1 plus y squared x, so we get 1 over 1 plus y squared x. And after that, we differentiate the function inside ln. So we multiply by, we differentiate 1 equals to 0. Plus, we differentiate constant times x. We still have constant here. Or, we can imagine, let's say we want to differentiate ln 1 plus 4x. Okay, we just imagine y equals to 2. So when y equals to 2, 2 squared equals to 4. So we get ln 1 plus 4x. When we differentiate ln 1 plus 4x, we have 1 over 1 plus 4x. And then times, we differentiate the function inside ln here. So we differentiate 1 equals to 0. Plus, we differentiate 4x equals to 4. So that's why when we differentiate y squared x, it becomes y squared. Because we treat y as a constant. Right? And after that, we can simplify. So we can write y squared over 1 plus x y squared. Okay? Alright, so after we find ux, we can find uxx. So the next step, step 2, we need to find uxx. Okay? Uxx means we differentiate ux with respect to x. And we treat x as a variable. At the same time, we treat y as a constant. To find uxx, we refer from ux. Okay? Ux equals to y squared over 1 plus y squared x. Since we treat x as a variable, so to avoid error and easy to differentiate, we can put variable x at the back and we use the different color. Okay? And then from here, we have division function. But we only have variable x in denominator. So means that we no need to use quotient rule. But we can move the function or the term containing variable x up. Okay, when we move up, so we get bracket to the power of negative 1 using the properties of indices. So from here, we get y squared times bracket 1 plus y squared x to the power of negative 1. And remember, y squared here means constant. So every time when we have constant times bracket to the power of any value, we can differentiate using generalized power rule. Okay? So when we differentiate ux with respect to x, the symbol is du. The symbol is uxx. Okay? Equal to, okay, from here, when we use generalized power rule, we move power to the front. So we get negative y squared. And then we copy the function in bracket. So 1 plus y squared x. And after that, we minus 1 from the original power. So we get negative 1 minus 1 equals to negative 2. And after that, we multiply by derivative the function inside bracket. So when we differentiate inside bracket, we get 0 and then plus, we differentiate constant x, so we get constant here. Or we just imagine, let's say we want to differentiate 4 times 1 plus 4x to the power of negative 1. Okay, 4 here because let's say we replace y equals to 2. So 2 squared equals to 4. And then 4 times 1 plus y equals to 2. So 2 squared equals to 4. That's why we get this. We just imagine. Okay. And when we have bracket to the power of any value with constant in front here, so we can use generalized power rule. So we move power to the front, so we get negative 4. And then we copy the function inside bracket. That's why we get this. And then we reduce 1 from the original power. So we get negative 2 here. And after that, we differentiate the function inside bracket. So when we differentiate 1 equals to 0. And then plus, when we differentiate 4x equals to 4. That's why when we differentiate constant y squared x, so we get y squared here. Okay? And after that, we can simplify. So we get uxx equals to negative y squared times y squared equals to negative y to the power of 4. And then times 1 plus x y squared bracket to the power of negative 2. So now we done find uxx from here. Okay? From the previous slide, we get uxx equals to negative y to the power of 4, 1 plus x y squared bracket to the power of negative 2. Okay, so after we find uxx, now we need to find uxy. Okay, so we continue with step 3, find uxy. Okay, to find uxy, we need to differentiate from ux. Okay, from the previous slide, we get ux equals to y squared over 1 plus x y squared. Alright, to find uxy, uxy means we differentiate ux with respect to y. We treat y as a variable. Okay? So to avoid error and easy to differentiate, we can write variable y at the back. Okay? And we use the different color in variable y. Okay? And then at the same time, we treat x as a constant. Okay. From ux here, we have division function. Okay. In numerator, we have variable y. And we also have variable y in denominator. Means that we need to differentiate using quotient rule. When we differentiate using quotient rule, we need to use formula vu prime minus uv prime over v squared. Alright, our u equals to numerator equals to y squared and v equals to denominator, which is 1 plus x y squared, right? Then we can differentiate y squared with respect to y. So we get u prime equals to 2y. Okay? And then when we differentiate 1 plus xy squared, we can imagine, let's say we differentiate 1 plus 3y squared. We imagine x equals to 3. Okay? So to differentiate 1 plus 3y squared with respect to y, we differentiate constant equals to 0 and then plus, we still put constant 3 in front here. Okay? And then we differentiate y squared, we have 2y. Okay? So when we differentiate 1 plus 3y squared, so we get 6y. Okay? Alright, now we want to differentiate 1 plus x y squared. So when we differentiate constant, it equals to 0. And then plus, when we have multiplication by constant, we just keep the constant in front. Then we differentiate variable y squared here. So we get 2y. Okay, then we simplify, so we get v prime equals to 2xy. Right? Right, after that, we substitute VU prime here. Okay, means we can cross multiply. So we multiply 2y and 1 plus xy squared. And then in between is minus. And then we multiply u and v prime here. So we get y squared times 2xy. So equals to 2xy cubed over v squared. We replace v by 1 plus xy squared and then bracket squared. Right? After that, we need to expand and simplify numerator. So we have uxy equals to, when we expand, we get 2y plus 2xy cubed and then minus 2xy cubed. Then we can simplify positive 2xy cubed minus 2xy cubed. So we can write uxy equals to 2y over 1 plus xy squared bracket squared. Now we find uxy. Okay? So we can continue with step 4. We show that left hand side equals to right hand side. Right? So from left hand side, we have 2uxx plus y cubed uxy equals to, we need to substitute uxx and uxy here, and then we need to show that right hand side equals to 0. So when we substitute, we have 2 here and then times uxx. So we replace uxx by negative y to the power of 4 times 1 plus xy squared bracket to the power of negative 2. And then plus y cubed. Okay, and then we replace uxy equals to 2y over 1 plus xy squared bracket squared. And then we can multiply 2 and negative y to the power of 4 here. So we get negative 2y to the power of 4. And then using the properties of indices, we can move down negative exponent here. So when we move to denominator, so we get 1 plus xy squared bracket to the power of positive 2. Okay. And from here, we get 2y to the power of 4 over 1 plus xy squared bracket squared. From here, we get the same term. Okay. But the first one in negative sign. And the second one in positive sign. So we can simplify and we get this function or this term equals to 0. So from here, when we compare, now we show that 2uxx plus y cubed uxy equals to 0. So it shown, right? Coming up next, more examples for higher order partial derivatives. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.